The southern region is the busiest part of British Rail's national network, and each day 5,500 trains pass over its 3,187 miles of track. In 1968, the trains running on the southern region were controlled by 544 signal boxes. Since the end of the Second World War, the southern region, which pioneered multiple aspect colour light signalling, has been extending this system. 1968 saw the start of a very ambitious plan, the control of the region from only 13 signal boxes. The first of these is Dartford, which was commissioned in November 1970. Before the scheme started, the Dartford lines were controlled from 41 signal boxes, and all will ultimately be abolished. These include small gate boxes where the operations could scarcely be considered efficient despite the personal service, and other local landmarks much beloved by many drivers, such as Dartford Junction, Crayford Creek, Crayford Spur A and B, and Perry Street Fork. Many of the old signal boxes were in poor condition, with most of the equipment life expired. Some dated from the 1880s. Nearly all the signals were mechanically operated semaphores, but within the area were two examples of pre-multiple aspect colour light signals dating back to the 1920s. These were direct colour light replicas of the aspects displayed by mechanical signals at night. Come for a short journey on an early morning rush hour train on the Dartford Loop line with the original signalling. The signal boxes are worked by the block system. This involves the sending and receiving of many messages in bell code, which is a very time-consuming process. Owing to the proximity of the River Thames, the area is prone to fog, when punctual running is impossible with semaphore signalling, as many passengers will testify. There is a shortage of signalmen, preventing signal boxes necessary for peak hour working being manned, causing delays when all other conditions are favourable. Detailed planning for the North Kent Line's re-signalling scheme was carried out during the latter part of 1967 and early 1968. The scheme was financially authorised in August 1968, and measuring and marking out on site commenced.
Signal D35, straight post, red light 12 feet above rail level.
Yes.
How about the base? 6 feet from rail, 6 inches below rail level?
Yes, that's all right.
We'll have the telephone on the post.
The first sign of physical progress is the installation of the cable route. The majority of this is concrete troughing, which is offloaded from special trains. The train is moved forward a set number of wagon lengths at a time. The control of the train movement is done by a supervisor on the track, whom the driver must obey implicitly. The purpose of this close control is to ensure that the correct rate of unloading is maintained. It is equally inconvenient to find too many or too few troughs available when laying commences. The offloading must be closely supervised to prevent the troughs being thrown out on top of one another and damaged. This is 10-inch troughing, but the most common size is 12.5 inches. 15 and 19-inch routes are used in more congested areas. Most of this type of work is done at night, increasing the difficulties. "50 trains were run with an average of 20 wagons containing 100 yards of trough each. The troughing is usually laid 6 feet from the inside edge of the nearest running line to allow mechanical track maintenance to be done. It is bedded into the ground a few inches to provide stability. A 19-inch troughing such as this weighs 220 pounds each trough. This part of the route is now taking 40 cables. The station platform is an obstacle to the cable route. There are 35 on the scheme where troughing is unsuitable and the route goes through the platform. Special tubes known as HEP ducts are laid in concrete in the platform and the surface reinstated. To assist feeding the cables through the tubes, manholes of 30 by 24 inches are provided at 60-yard intervals. Asbestos tube routes are used where the ground is unstable and also over viaducts and under bridges. Before acceptance of the route from the contractor, a joint inspection is carried out. The route crosses under the track at 36 locations and this is done using asbestos tubes set in concrete 4 feet below rail level between manholes on each side. There is about 50 miles of cable route of all styles. This was installed at the rate of a mile a week. While the troughing is being laid, a start is made on bases for the new colour light signals. Due to the difficulty of obtaining occupation of the line for material trains and the large number of bases required, the contractor decided to dig and cast these in situ. In this way, 10 bases were completed each week. There are 257 main running signals on the scheme. Most of these are simple straight posts in the latest standard design using a 5.5-inch diameter tube. The majority of the signals are 4-aspect, red, yellow, double yellow, green, with 3-aspect on the countryside of Dartford. The lamp in each aspect is 12 volts with a 24-watt main filament. If this fails, an auxiliary 24-watt filament is automatically switched on and warning given of the failure in the signal box. Immediately a signal is erected, a cross must be placed on it, indicating that it is to be ignored. This fiberglass hood allows the signal to be switched on for test purposes. Where simple posts cannot be erected, purpose-made structures are provided. Special care is taken to give the driver a good view where the line zigzags through cuttings and tunnels between Greenwich and Woolwich. Construction of the new signal box at Dartford commenced in October 1969. The southern region have adopted the clasp system of building construction for its signal boxes, relay rooms and other railway buildings. CLASP stands for the Consortium of Local Authorities Special Programme and is a prefabricated system of building using standard components. It starts with a good foundation on which is placed a metal framework clad with concrete panels. The base for the Dartford Signal Box, which you see under construction, is 150 feet by 27 feet. This was completed in just over a week. The wooden box forms a cable duct running the full length of the signal box. The entire metal framework was erected in only 2.5 days, and the concrete panelling, some of which you see stacked on the right, was fitted in a further 5 days. 5 months after commencement, the building was available to the signalling contractor. The railway is closed several weekends to allow extensive modifications to be made to the permanent way. The layout of the London end of the station takes 3 weekends, as each Monday morning the up rush hour trains must run. The first weekend is fine and frosty, and work concentrates on the new connections on the down North Kent line. The area civil engineer keeps an eye on things. The signal engineers' supervisors wait to start their work when the new layout is positioned. new electric point machines arrive even before the ballast. The second weekend starts wet and miserable, heavy rain falling throughout the night. This time, the up line and the down loop receive attention. The main purpose of these alterations is to provide reversible working on the middle line between Dartford Station and Dartford Junction, and to allow for a fourth platform at the station. As the slips are repositioned, the rain eases. The day continued to improve, and the wintry sun breaks through. Altogether, 12 new point machines are fitted to the new layout at the London end. After the third weekend, the job is complete. The new rusty crossover cannot be used until the new signalling is introduced. Dartford Junction is completely rebuilt in 43 hours. 3 works trains, each with a crane, take over at 10 a.m. one Saturday. They lift the straight track and lay in pre-assembled point turnouts. The completed layout, which allows maximum flexibility of operation between both arms of the junction and the central reversible line, is seen here, ready for the new signalling. At the country end of the station, the layout is simplified and the down carriage siding extended to take a 10-car train. Insulated fish plates are installed for the final track circuitry. During all the alterations, new point machines are fitted, temporarily controlled from the old signal box where necessary. The complete layout, seen here, allows for the fourth platform. The most expensive individual part of any signalling scheme is the provision of cables. Most of the cable on the scheme is laid from special trains. Each wagon is fitted with fixed jacks to take 2 cable drums. Careful preparation is required to ensure that cables are readily identifiable and mounted the correct way round for the running direction of the train. Where possible, all cables along a stretch of line are laid together. On average, this is 4 cables, a 2-core power supply cable, 2 signalling multi-core control cables, and a telecommunication cable. A remote control microcore cable is also laid where required. The average train carries 24 drums of cable, and 12,000 yards of cable over 2 route miles is laid in the possession of 5 hours. Cable trains usually require both running lines to be completely blocked, and this work has to be done at night. 51 cable trains were run. Hand pulling is the most efficient way of laying cable in areas where obstructions prevent satisfactory laying from trains. It can be done during normal working hours without affecting train running. All power supply and signalling multi-core cables are to British Railways specification 972A, with copper conductors, polychloroprene, insulated and sheathed, unarmoured. All telecommunication cables are generally in accordance with British Railways specification 984, with £10 or £20 copper conductors, polythene insulated and sheathed, unarmoured. Altogether, 48 miles of power supply cable, 150 miles of signalling multi-core cable, and 85 miles of telecommunications cable are installed on the scheme. At outside locations, the cable cores are terminated on 2 BA terminals with sliding disconnection links. In relay rooms, cables rise out of the cable duct and are terminated on fuse bases. junctions at Blackheath and Charlton will ultimately come under the control of the new London Bridge signal box. The final interlocking for these junctions is housed in a relay room at Angerstein. For the time being, the control is from a small wing panel housed in the existing signal box at St. John's. This arrived early one morning during the rush hour. This cumbersome method of installation avoided the need for special equipment, craneage, and blocking the line. This stage, with 83 signal sections, which introduced colour light signalling to 12 stations, was the first to be brought into use and had an immediate impact on train running. The Dartford control panel arrives more ceremoniously. 3 lorries set out one evening from Darlington, carrying the panel in 6 sections, and arrive at Dartford on what turned out to be the hottest day of 1970. A mobile crane with telescopic jib is waiting to offload the sections into the hole left in the front wall of the operating room. Each section weighs nearly a ton when fully assembled. This panel is currently the largest on the region with a length of 50 feet. The operating surface is inclined 5 degrees from vertical. The faceplate is of domino construction. For access to contacts and lamps, a magnet is used. Lamps are easily changed, which is just as well as there are 4,000 of them. Cathode ray tubes, used for train describer display, are also easily accessible. The tube screen size is 2 by 1 inches. Each tube is covered by a special Polaroid non-reflective filter. The scheme takes power at 415 volts single phase from 11 traction substations. This is transformed to 650 volts, the standard used for signalling line-side distribution. All supplies are fully duplicated. The largest transformers are 55 kVA at Dartford Junction, where the normal supply for the new signal box is obtained. In the event of a failure of the substation supply, an emergency supply is taken direct from the electricity board through an automatic changeover contactor installed in the signal box. The 650-volt supply is transformed to 110 volts at line-side locations and relay rooms to operate track circuits and signalling relays. Points are operated by electrically driven DC machines. They comprise an electric motor, clutch, gear train, throw bar, lock and detector slides, and contacts. The motors are controlled by contactor relays to British Railway specification 943. The 120-volt DC point operating supply is obtained from batteries in relay rooms or from 650/120-volt transformer rectifiers housed in line-side locations. These units are designed for simple replacement. The machine can be used for special layouts, such as this long switch with 3 drives and 2 locks, or double slips. The relay interlockings are laid out geographically using plug-in sets, which are factory wired, tested and sealed before delivery. The rack plug boards are resiliently mounted to line up with the set contacts. The holes above the contact blocks receive interlocking pins. This ensures only the correct unit type can be plugged in. Each interlocking is provided with a test unit. Relays to British Railway specification 930 series are plugged into the sets. A further non-interchange arrangement ensures only the correct relay type is plugged in. When all the relays have been plugged in, power is switched on, and testing commences. You see in progress the testing of route locking. This is done by simulating train movements from a test panel and ensuring that points remain locked until after the passage of trains. The route under test is denoted by a line of white lights, and the position of the train is seen as the white lights change to red. A third member of the testing team records each test as it is made. Testing is not only confined to the signal box.
Signal AWOL to Signal Baker. Signal D42 displaying 1 red. Displaying 1 yellow. Displaying 2 yellows. Displaying 1 green. Over.
Route setting is done by the NX entrance-exit method. To set a route, the entrance button is pushed until it flashes. The exit button is then pushed, white route set lights appear, and the entrance button light becomes steady. When all points are in the correct position, the line of white lights is continuous and the signal clears. White lights also denote the extent of overlap. You see here a normal overlap. Sometimes a full overlap is not available. A second exit button is then used to set a reduced overlap. The clearance of the signal is then delayed to check the train. In the case shown, after a route is set into the sidings, a reduced overlap is set into the platform. A feature of the system is that although a delayed clearance route has been set, the setting of the route ahead will cancel the delay of the first signal as shown. You see this again in close-up. Overlaps may be swung automatically if there is a free overlap available when a conflicting route is set. In this simple case, the overlap for the down route is lying into the sidings. Calling the route from the up platform automatically swings the overlap out of the way. In this more complex situation, there is an overlap for the down route set round the spur, and an overlap for an up route into the spur extending foul of the up main. Calling a route up the main will now swing both the other overlaps into alternative positions, allowing the up main route to clear. When a route has been set, it will only release after the passage of a train. If the entrance button is pulled before this has occurred, the route is held for 2 minutes. During this period, the signal indication flashes. Overriding controls can be used if there is a remote control failure. A 3-position switch is provided, which in the auto position allows through running to take place. In the signals on position, all signals are returned to danger. This is how it operates at Gravesend. When the signals are returned to danger, all routes are held for 2 minutes. A systems indicator is provided in the relay room for each interlocking. This shows the state of the interlocking during route setting to assist fault finding. After a route has been called, the next route cannot set until the green light reappears. A counter is provided to record routes set for each interlocking. During a typical rush hour, 220 routes are set in Dartford relay room, and the total for the first 3 months was 200,000. The train describer is of the 4-digit type with a display for each signal. A description can be set up manually by the signalman and interposed for display at any signal. The description will thereafter follow the movement of the train. Now we will see this again. The strobe effect seen on these displays is not visible to the operators. Areas with points and controlled signals remote from Dartford, such as Plumstead, Northfleet, Gravesend and Sidcup, shown here, are controlled from a local interlocking housed in a small relay room operated over a microcore cable link. The interlocking itself is standard geographical as installed at Dartford. The relays at each of the microcore cable links are miniature post office type. Each relay is connected to one line of the microcore cable and its common return wire. The cable consists of 238 cores of 0.0148 inches, that is about 15 thou diameter, copper wire, with a flexible center core of a 1/4 inch diameter. It's provided with an aluminium tape moisture barrier and a brass tape for rodent protection. This type of remote control is only economic for distances of up to 7 miles. Microcore cable can only be manufactured in nominal 500-yard lengths, and as 31 miles of this cable are required for the scheme, 107 joints such as this are required. The 238 wires are enclosed by this sheath after 6 hours' work. In the event of failure of the microcore link, override control is available as demonstrated previously. This only allows for through running. If full facilities are required, a local operator can use an emergency panel in the remote relay room. Routes are set on direct instruction from the Dartford signalman. Before the introduction of the signalling scheme, communication between signal boxes, stations, etc., was by code-ringing omnibus telephones connected to the overhead pole route. The pole route has been replaced with an audio cable, terminated in apparatus cases at 2,000-yard intervals with loading coils connected to certain cable pairs. All telephones, other than signal post telephones, are automatic, connected to a new exchange housed in Dartford Signal Box. This forms part of the region's telephone network, and the exchange is linked to the zone centre at Beckenham via 12 circuit carrier systems, the equipment seen on the left. The gas pressurisation rack on the right maintains a pressure of 9 pounds per square inch in all main telephone cables. These are continuously monitored. Every main signal is provided with a telephone connected direct to the signalman on the control panel. Similar telephones are provided at ground frames, gate boxes, adjacent signal boxes, and for shunters and platform supervisors. There are 260 telephones on the control panel concentrators. Telephones are also provided adjacent to points for the use of maintenance technicians and the traffic department. From this desk, the train regulator has direct communication to all platform supervisors, traffic and electric traction controllers, and the post office network. The teleprinter receiver from Beckenham Traffic Control. The information operator communicates with all the stations in the area and the regional network. At a later date, he will operate the public address at Dartford Station and a long-line public address system to all stations in the area. Coincidental with the re-signalling, electric point heaters are installed. The heater elements are inserted in holes drilled in stock rail chairs or clamped direct to the stock rail. When snow is forecast, the signalman switches on. Frozen points are almost a thing of the past. Trains continue to run. And so to the actual changeover. In the first few minutes of Sunday the 1st of November 1970, after the last train has been berthed, all lines in the Dartford area are blocked and the traction current switched off for a possession of 8 hours. 230 men are already in position throughout the area. 115 new colour light signals are uncovered. Further gangs of men start to demolish 125 old semaphore signals. At Dartford Signal Box, the nerve centre for the night's work, engineers anxiously await reports of outside progress. Each new signal uncovered is reported and tested from the box. The demolition gangs work to a very tight programme. There is little spare time for unforeseen problems. As point machines are reported changed over, they are tested from the new panel and placed into service. Every signal and route is operated from the panel using the actual points and track circuits. train describer equipment is tested once again. Towards the end of 6 hours intensive work, the outside supervisors report in that demolition is complete and sections of the line are clear and ready for traffic. Daylight shows that the Dartford platforms have been renumbered in anticipation of the construction of the additional platform. The work completed, the possession is handed back 10 minutes early, and the route is set for the first train to leave the sidings for the station. Punctually at 08:55, the train leaves Dartford Station for London.